So the second part of 18.2 is just solving the word problems using the quadratic formula. So we're going to set all these word problems up the same. They're word problems you've seen before, but when we get the quadratic at the end, it won't be factorable, and we'll just use the quadratic formula to solve, and that's the only thing that's different. So way back when, like 13.6, so one of the very first sections, we had this, remember how it's like, instead of walking the sidewalk, if you just cut across that triangle, you saved yourself some walking distance? So we did that, we set it up, and then we got a factorable equation. So let's see what's going on here. It says, at a local university, students often leave the sidewalk and cut across the lawn to save walking distance. I'm guilty of that, I'll admit it. Given the diagram below of a favorite place to cut across the lawn, approximate how many feet of walking distance a student saves, okay, so we want to know about student saving, by cutting across the lawn instead of walking on the sidewalk. So this is an instance where once we find x, we're not necessarily done, because x is just the distance of this sidewalk, and then we'll add 20 as the distance of that sidewalk. So when we find x, we're going to plug it back in to see how much that student walked if they walked the sidewalk compared to the 50 feet if they just cut across. What shape do you guys see? A triangle, okay? So remember, when you have three sides to a triangle, what can you always use? The Pythagorean theorem, okay? That's the a squared plus b squared equals c squared. And we just did that in like 17.6 or something like that. All right, what is one leg of the triangle? X. So we have x squared plus, what is one leg of the triangle? X plus 20, put it in parentheses, equals this longer side, the 50 feet squared. All right, so what we're going to do is we're going to go back through and square the things we can and FOIL the other things. So this x squared doesn't really need parentheses. That will just be x squared. X plus 20 squared, though, is x plus 20 times x plus 20. And then 50 squared, throw that in your calculator. I think you get 2,500 when you do that.
Yeah.
So what you're starting to see to develop is a quadratic formula. So you're like, okay, well, I have an x squared and I have a constant, but then I have these like two things back to back. So let's go ahead and FOIL them. So this is going to be x squared hanging out. And guys, I'm just going to do a shortcut real quick. So x times x will be x squared. But x times 20 and x times 20 twice will add up to 40x, just to save us that one step, all right? And then 20 times 20 is 400. Equals 2,500. So I kind of quickly FOILed that. So x times x is x squared. X times 20 is 20x, but then 20 times x is 20x. So 20 plus 20 will give us that 40x. And then 20 times 20 is 400. At this point, what do we need to do? Combine like terms, get everything to the same side, okay? So what is 1x squared plus 1x squared? 2x squared, right? So we have a 2x squared plus, nobody can combine with a 40x, so he'll stay a 40x, and then I'm going to subtract the 2,500 over to get a negative 2,100 equals 0. And look what we have. We have a quadratic equation, okay? So your first move with the quadratic equation, you don't have to do this, but I do it. I still factor out the GCF. Why? Because one, once I factor out the GCF, I might see a really quick, easily factorable equation, which I'd rather factor than do anything else. And two, even if it doesn't factor, your coefficients get smaller, and so it makes the quadratic formula easier to use, okay? So what can we take out of 2, 40, and 2,100? The only thing we can take out, guys, is a 2, okay? So go ahead and factor out a 2. And what will we have? We'll have x squared plus 20x, and then 2,100 divided by 2, guys, is 1050 equals 0. Okay? And this is what I'm talking about. Instead of wasting our time and thinking, okay, my a is 1, my c is negative 1050, what are negative factors of negative 1050 that might add up to 20? I don't even know if they exist. We can go right to the quadratic equation. Do we need to worry about this 2 in the quadratic equation? No, he does not have an x. Technically, we could divide both sides by 2 and just be done with him. So we're just going to focus on this guy, okay? So what is the a term? What's the coefficient for x squared? 1. 1. I'm going to put it in there. A is 1. What's our b term?
20.
20. And what's our c?
Negative 10.
You got it. Okay. So again, I'm writing the quadratic formula. I'm going to start way over here, guys, because there's kind of a line that will go. So we'll have x equals negative b plus or minus the square root, b squared minus 4ac all over the 2a. And we already know what a, b, and c are. Okay, so we're going to plug it in. My b is positive, so when I plug it in, it'll be a negative 20 because of the formula, plus or minus the square root of 20 squared minus 4 times a, which is 1, times c, which is a negative 1050, all over 2 times a, or 2 times 1. All right, so what we're going to do is we're going to leave negative 20 hanging out, plus or minus the square root, and then let's figure out what this number is, and then it's going to be all over 2 times 1, or 2. So in our calculator, even though it's kind of bigger numbers, that's okay. In our calculator, what we're going to do, guys, is we're going to go ahead and type it exactly how we see it. Over here, maybe, do that. Okay. So I'm going to do 20 squared minus 4 times 1 times negative 1050. Do you guys get a positive 4,600?
Yes.
Does that look okay? So I'm going to type 4,600 in here. What's nice about this specific problem, the cutting the lawn problem, if you read the problem, which it doesn't have it here, but if you read it in my math lab, it'll say, how much does the student save round to the nearest hundredth of a foot? If you're rounding, that's when you're like, yes, I don't have to break this down. I can actually just put it in my calculator and get my answer, okay? So, what is this? I'm going to write it over here. X equals negative 20 plus the square root of 4,600 all over 2, and we'll get that answer. Or x might equal negative 20 plus or minus the square root of 4,600. Or not plus or minus, minus, we already did a plus, minus all over 2, okay? So what I'm going to do is in my calculator, I'm going to do negative 20 plus the square root of 4,600, hit enter, get a decimal answer, and divide by 2. So I'm going to just type negative 20 plus the square root of 4,600, hit enter, and then divide by 2. So that's 23.91. And then I'm going to do the same thing, but I'm going to do it with the negative. So I'm just going to type negative 20 minus the square root of 4,600, hit enter, and then divide by 2, and I get negative 43.91. Does that look okay for those that did it on your calculator? Okay. So what we have to realize is we have come up with the two potential values for x. But what was x standing for? X was the distance of a sidewalk. Can the sidewalk be negative 43 feet? No. So what x do we technically have? This. And he's not the answer, though. We still have 2 more steps we have to do. I know, right? So hopefully you still have room where we can go back up here, like under the picture, whatever we need to do. So the 2 steps we need to do is we need to plug x in to see how much you would be walking if you walk the sidewalk, okay? So get a total distance for the sidewalk that we're going to walk. And then we'll subtract 50 to see how much we save, okay? So the sidewalk, guys, is what? Well, that was x plus 20. Do you agree with that? X plus 20. So it'll be 23.91 plus 23.91 plus 20, which equals what? 67.82. Is that okay? So the sidewalk, if we walk the sidewalk, we'd walk almost 68 feet. But if we cut across, how many feet do we walk if we just cut across? 23. We're going to save ourselves 23 something, okay? So minus the 50, the cut across, should it be 1782 we'll save? See what I did there, guys? So if we walk this sidewalk and this sidewalk, we walk a total of 67.82 feet. But if we just cut across this diagonal, we'd only walk 50 feet, right? So how much did that save us? That saved us 17.82 feet. We did this exact same problem, like if you go back and look at your 13-6 notes, we did this exact same problem, but when we got to this point, the quadratic was factorable, and that's how we could solve it, okay? So the only difference is you're going to get to a quadratic that's not factorable, so what can you always use? The quadratic formula. Look at number 2. This guy is nothing new here. A rectangle is 6 more meters long as it is high. So what shape are we dealing with? A rectangle. Do we know how tall or long it is? No, but we know it's 6 more meters long as it is high. So since it's talking about the height, we'll put x, and how do we show 6 meters more than that?
Plus 6.
X plus 6 for the length there. You got it. So what do we know? It says the area is 22 square meters. So this area is 22 square meters on the inside. Find the dimensions of the rectangle. So we want to find x, and once we find x, guys, we'll add 6 to it to get the length. What's the area formula for a rectangle?
Length times width.
Length times width. Do we know the area? Yes. They told us the area was 22, so we'll put a 22 for the A. Do we know the length? Not specifically, but we know it in terms of x. That's x plus 6. So I'm going to put parentheses around my x plus 6. And then do we know the width? Not specifically, but we know it's x. So this is something, I think we even had it like on one of our quizzes, right? So what we need to do is we need to get rid of those parentheses. How are we going to get rid of those parentheses? What do we need to do? Distribute that x, okay? So the x will go here and here. So we'll have 22 equals x squared plus 6x, and what do you see forming? A quadratic equation. So what do we need to do with this quadratic equation? We need to move the 22 over, so we'll have 0 equals x squared plus 6x minus 22. Are there factors of 22 that add up to 6? No. 22 only splits up to 2 and 11. There's no combination of that to get you 6. So what can we use? The quadratic equation, or formula, excuse me. What is A, technically? A 1, so I'm going to put them there. B is a 6. C is a negative 22. All right? So again, I'm going to write it generically every time. X equals negative B plus or minus square root B squared minus 4AC all over 2A. And we have everything labeled, so we'll just go back in and put everything in. My B is positive, so it will stay a negative 6, plus or minus the square root of B squared, which is 6 squared, minus 4 times my A of 1 times my C of negative 22. And that will be all over 2A, or 2 times 1. Let negative 6 hang out as you calculate what's under the square root, okay? So we'll have negative 6 plus or minus the square root of some number, all over 2. We'll have negative 6 plus or minus the square root of some number, all over 2. So this will be negative 6 plus or minus the square root of something over 2. And I'm just typing that in my calculator, guys. Big glare. Okay. I'm going to clear it out. So we have 6 squared minus 4 times 1 times negative 22. Do you get 124? Does that look okay? Okay. So we have the square root of 124. So for some reason on this problem, they don't say round to the nearest foot. They want the exact answer on this one. Okay? So when they say, give me an exact answer, that means they want that radical broken down. So 124, guys, is an even number, so we know it's divisible by 2, okay? So this will be 2, and then if you take 124 and divide by 2, you get 62. But 62 is an even number, so it's divisible by 2 as well, so you get 2 and 31, okay? So since it's a square root, we're looking for a pair, so we have a pair of 2's. So x equals negative 6 plus or minus, who can come out? The 2, who stays in? 31. The 31, all over 2. All right? And then, what do we notice about each term? The negative 6, the 2 root 31, and the 2, they're all divisible by 2. So this will be negative 3 plus or minus root 31 and that's it, right? We divide everything by 2. So negative 6 divided by 2 is a negative 3. This 2 knocks out, but you have the root of 31, and that 2 becomes a 1, but we don't do over 1. So what is x again? Remember, x is a length. So our two values of x are either negative 3 plus 31, or x equals negative 3 minus the square root of 31. What type of number is this going to be? A negative minus a negative is? Nope.
Nope, negative.
Negative, right? If you're in debt and you go spend more money, you're more in debt. This is negative. I don't even care what it is. The fact that it's negative, I don't want it, right? So what is x? X is negative 3 plus root 31. So what is that? That was our width. So our width is, guys, negative 3 plus the square root of 31 meters. How do we find our length?
Isn't it just that plus 6?
6, right? Okay. So bear with me. So we know our length is this going to be the exact same number plus 6. But if you add 6 to this, can you add 6 to the root 31? No. But can you add 6 to the negative 3? Yes. So what is our length? Positive 3 plus the square root of 31 meters. Because your length is x plus 6. This was x. When I add 6 to it, the 6 and the negative 3 combine to be a positive 3. And I think that always happens, guys, where like this negative number in front will always turn up being the positive number for the length. I don't know why that works that way every time, but I think it does. Okay, so the length was x plus 6, so x was kind of ugly. It was negative 3 plus root 31. And then if we added 6 to it, we could add the 6 to the negative 3 to get a positive 3. If you want an approximate answer, guys, you can always just throw that in your calculator. So if they say approximate it, we just do negative 3 plus the square root of 31. So the width is approximately 2.6 meters, and then the length would be 3 plus the square root of 31. So the length would be 8.6 meters, okay? So you could plug it in and get an, and that makes more sense to me. If we need fencing, I want it in meters, not square roots. All right, last one, guys. This is the ultimate word problem where if you are going on in math, college algebra, calculus, whatever it may be, this word problem is going to follow you everywhere, okay? So it's that typical, an object is thrown upward, so we make this parabola. I throw it up and it makes this arch, it makes a parabola. When will it hit the ground, or when will it be this high, blah, blah, blah. What's nice about these problems is that they always give you the equation, okay? So it says, an object is thrown upward from the top of a 200-foot building or cliff with a velocity of 12 feet per second. We don't really need to know that because they already use these to come up with the equation. So the height h in feet of the object after t seconds is this. So this is the equation we're going to use, okay? So it says, A, how long after the object is thrown will it strike the ground? How long is asking us to find time, okay? And wants us to find the time when the object hits the ground. But if it hits the ground, what is h if it's hitting the ground? How high is it off the ground if it hits the ground? 0. Okay? Remember doing these before? So we just put 0 here and we would factor this. Well, guess what? Now we have a quadratic that's not factorable, all right? So what we're going to do is we're going to take this equation and we're going to put 0 in for h, and we're going to write negative 16t squared plus 12t plus 200. If you want to, you can factor out a negative 4. If not, it's not a big deal, okay? This is exactly how we have it. So let's write an a, a b, a c. So we can use the quadratic equation. But instead of x equals, it'll be t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. My b is positive, so when I plug it in, it'll be a negative 12 plus or minus 12 squared minus 4 times my a of negative 16 times my c of 200 all over 2 times a, or 2 times negative 16. Okay? So what I'm going to do is I'm going to let the negative 12 hang out, plus or minus, and come up with a number over negative 32. Okay, so we're going to type this. It's big because we didn't factor out a GCF. That's fine. It'll be big. That's okay. Our calculator can handle it. So we have, I'm trying to do it so we can see everything. 12 squared minus 4 times negative 16 times 200. Get 12,944. But notice it says round to the nearest tenth of a second. That means we can do our answers, okay? So what is t going to be? T is going to be negative 12 plus the square root of 12,944 over negative 32. Or t is going to be negative 12 minus the square root of negative 12,944 over negative 32. And be careful because they're kind of tricky since we're dividing by a negative. I think this negative one ends up being the winner, but let's just see. We can plug both of them into our calculator. So I'm going to do negative 12 plus the square root of 12944, close off my parentheses, hit enter, and divide by negative 32, hit enter. I get negative 3.2 seconds. So we don't want that, right? Time is never negative. So we don't want that. So we're going to want this positive answer, okay? So we're going to do negative 12 minus the square root of 12944, close off your parentheses, hit enter, divide by negative 32, and you get a positive 3.9 seconds. Does that look right to those that are plugging it into your calculator? Okay. So what does that mean? It means if we really threw it off of this 200-foot cliff, it would take about 4 seconds to hit the ground, which is pretty impressive. I mean, that's a pretty quick fall based on this. So again, key thing, they're going to ask you how long, so they want you to find time. And so then they're going to have to give you a height. So here in this case it was ground, so height was 0. Notice on B, the only difference is how long. So again, it's asking us to find time. After object's thrown, will it be 100 feet from the ground? So what is h now? 150 feet. And that's the only difference, is that we're going to plug 150 in for h, okay? So the same equation from above, way up there. Can I get it all in the picture? We're going to use the same equation from way up here, but now we want to know when it's 150 feet from the ground. So we're going to have 150 equals negative 16t squared plus 12t plus 200. Okay, so the exact same equation, but I'm putting 150 in for my height. What am I going to have to do with that 150, though, if I want to use the quadratic equation? Subtract it over, exactly. So you get 0 equals negative 16t squared plus 12t, is that plus 50? Is that what you get? Yeah. And then that's just the new quadratic, okay? So this will be A, B, and now our C is different. So it should be a shorter time, because instead of falling the full 200 feet, it's really only falling 50 feet. So our time in seconds should be a little bit smaller. So again, t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that will be negative 12 plus or minus the square root of 12 squared minus 4 times a, which is negative 16, times my c of 50. So that will be a lot smaller. Over 2 times a, or 2 times negative 16. So I'm just plugging it all in, okay? So I'm using that quadratic formula. T equals negative b plus or minus b squared minus 4ac all over 2a. Let negative 12 hang out, let the negative 32 hang out on the bottom, and do the inside. It should be a smaller number than the 19, whatever we got above, all right? So this will be equals negative 12 plus or minus something over negative 32. What do you guys get when you put that in your calculator? 33.4. I got 8. Oh, no, you're right. Hold on. I got 1672. Did I do that wrong? Okay. Let me try it real quick. Can we see it yet? So I'll do 12 squared minus 4 times negative 16 times 50. No, you got it. 3344. All right. And again, since it says round to the nearest tenth, That's your sign that you don't have to break that radical down. You can just put it in your calculator. So what are our two answers for t? T equals negative 12 plus the square root of 3344 all over negative 32, or t equals negative 12 minus the square root of 3344 all over negative 32. And just throw those in the calculator. So I'll do negative 12 plus the square root of 3344, hit enter, divide by negative 32. I got negative 1.4 seconds. Does that look right? And again, I don't want time to be negative. So negative 12 minus the square root of 3344, hit enter, divide by negative 32. I got positive 2.2. Anybody get that? Is that what you got, Anna?
Yeah.
Okay. And it should be shorter, right? Because instead of falling the whole distance of the 200-foot cliff, it's only falling 50 feet.